Good morning, everyone. Welcome to the fourth edition of Cengrs Geotechnica Private Limited series titled Advances in the State of Practice of Geotechnical Investigation in India. Today, we will be exploring the geotechnical investigation practices which apply to Indian sites. Our speaker, Mr. Ravi Sundaram, Director of Cengrs Geotechnica Private Limited, with over 44 years of experience in the geotechnical engineering industry, his expertise includes geotechnical investigations, geophysical surveys, ground improvement, and groundwater studies. He has published over 70 technical papers that reflect his experience in geotechnical engineering practice. He received IGS Professor Dinesh Mohan Memorial Award for Excellence in Professional Practice. He received the IGS Delhi Chapter Lifetime Achievement Award in 2012. He also delivered the prestigious 6th Madhav Lecture in honor of Professor Madhav, former Vice President Asia, in 2017. He is a member of several committees of the Bureau of the Indian Standards and committees of the Indian Roads Congress. Before we start, I encourage everyone to participate actively, drop your questions and comment in the chat box, and we'll address them live. Your engagement makes these webinars truly enriching. So don't hesitate to share your thoughts. Over to you, sir.
Welcome everyone to this edition of Cengrs online webinar. At Cengrs, we always believe in technical sharing of knowledge, and we have always tried to share technical information with all our clients, our well-wishers, other geotechnical practitioners, and as we now move on to this this webinar, I will be talking today on the advances in the state of practice of geotechnical investigation in India. Geotechnical investigation, as you know, is a very important aspect of geotechnical studies, and the investigation is what provides the necessary data for the foundation analysis. So if you can get good quality data, of course your foundation analysis is going to be superior. And that is what we shall try to explain over the next 45 minutes or so. As you know, geotechnical investigation practice has been rapidly evolving from the classical era in the 20th century. The masters like Terzhaghi, Peck, Horslev, Skempton, and many others have done a lot of pioneering work in popularizing geotechnical investigations and trying to bring forth the importance of investigations for foundation analysis. But as we move on to the 20th century, the new developments and demands of geotechnical practices has led to a greater emphasis on in situ tests, advanced testing tools, and most importantly, digital data acquisition. So with all this, we are able to address complex geotechnical problems afresh, generate better quality data, and face the challenges which the new generation of geotechnical engineers routinely face. Now, when we talk about what are the challenges in the current century, the conventional methods of investigation need to be expanded on for design of modern structures like tall buildings, metros, railway structures, bridges, refineries, thermal and nuclear power plants, solar power plants, dams, hydraulic structures, etc. Actually, the thrust has now been on developing more realistic design parameters, uh, not go with conventional kind of conservative approaches. You may want to encroach upon the factor of safety, but still enhance the factor of reliability. So it becomes more important that you increase your reliability rather than factor of safety. So realistic design parameters. Now, when you are going to use powerful finite element software, then you need better quality and more reliable geotechnical input data. So the addresses that need to, the aspects that need to be addressed, these include perform a variety of in situ tests and laboratory tests so as to predict the parameters from different tests, develop correlations between the various parameters, enhance the precision of the tests, the quality of data acquisition, and ensure that the reliability of the test data is good. Most important, of course, is local experience so that you minimize the uncertainties in the selection of geotechnical parameters. There is a big need for upgrading geotechnical investigation methods. So now in India, also agencies involved in geotechnical investigations are upgrading to adopt the new technologies. Several technologies that are now available in the country are able to enhance the quality of the geotechnical data. Some such tests I will touch upon in this presentation. SPT energy measurement, electric cone penetration test with pore water pressure measurements, pressure meter tests, electrical resistivity tests, electrical resistivity imaging, other geophysical tests like seismic tests, cross-hole seismic refraction tests, SASW, MASW, etc. I will be presenting one case study demonstrating the benefit of these technologies. But let us first look at what are the modern technologies which are now being used in the country. First, I will talk about SPT energy measurement. SPT energy calibration, this normalizes the energy transfer to the SPT sampler head. It removes the scatter in the values and enhances the reliability of the data. The N value should be standardized to 60% energy transfer so that it is all uniform level. If we have different equipments which transfer different percentages of energy, anything ranging from 40% to 95%, the N value will not be comparable. So if you can standardize it to a 60% energy transfer level, then it becomes consistent. So the SPT analyzer, this equipment has a 0.6 meter long drill rod instrumented with 2 strain gauges and 2 accelerometers. It is inserted at the top of the drill string here. So I just present a case study in Noida. Here we were able to get an energy transfer ratio of about 77.9%. So your N values which had been measured, these can then be corrected to this much energy transfer. I also look at electric cone penetration test. This equipment, you have a cone which has which measures the tip resistance, the friction resistance, and also the pore water pressure. There is a pore water pressure sensor at the just above the cone. So now these are all having sensors which can give digital data to the data acquisition system which is there on the ground level. So this is called the piezo cone. So you can see a piezo cone here. So it is better for assessment of strata conditions and particularly for liquefaction assessment. The CPTU, as it is called, records continuous penetration resistance, frictional resistance, and pore water pressure during the penetration of the cone. Currently, the test method is as per the ASTM, but now this is being incorporated in the IS code, and a new draft code is under preparation. It should be out soon. So the CPT will soon be in the IS code. The cones with cross-sectional areas of 10 square centimeter and 15 square centimeter both are popular. The 15 square centimeter cone gives better results and is more popular. The porous element for the pore water pressure measurements is just above the cone there. So that's how the piezo cone looks like. So it has this pressure sensor which measures the pore water pressure, and the data collection is electronic. So you have connected to a computer. As a result, it eliminates all the human errors. You may also be familiar with the pressure meter test, the Menard's pressure meter, and the dilatometer. Both these tests are finding applications in India on several major projects. Usually, the test is done in pre-bored boreholes. Self-boring pressure meter is presently not available in the country, but may be available soon. Parameters that are determined from the test are the limit pressure, the deformation modulus, in situ horizontal stress, unconfined compressive strength, pre-consolidation pressure, over-consolidation ratio of clays, etc. So that's the pressure meter test equipment. You have a control panel and a probe. There is a coaxial tube connecting the probe to the control panel. There is a gas cylinder which controls the pressure in the guard cell. So the commonly used probes, you have equipment up to 80 bars. So the soil bars with the probe with a rubber cover is usually used up to 25 bars, and the rock probe with outer cover of steel strips, this can go up to 80 bars. The equipment of capacity 200 bars also available. The 200 bar equipment is good for rocks. Since bearing capacity and settlement is usually not a problem in hard rocks, the 80 bars equipment is suitable for most applications. In certain specific requirements where you need to understand the behavior of the rock, the 200 bar equipment may be used. The standard probe diameters are AX, BX, and NX. The popularly used diameter is NX. The typical result of a pressure meter test, before you do the test, you would expand it in air to understand the stiffness of the rubber membrane itself, and then you would do the test pressure versus volume, and you would subtract the air the stiffness of the probe from the air calibration to get the corrected curve. You also have to correct it for expansion of the hoses. This is done by expanding your probe within a rigid steel pipe. Now we go on to geophysical tests like electrical resistivity test. So the conventional electrical resistivity test usually done by the Wenner configuration. You could also use the Schlumberger configuration. So here you, for the Venner configuration, you have 4 electrodes spaced equally apart, and the apparent resistivity is calculated as 2 pi V by I. Here you have the potential electrodes inside, and the outer electrodes are the current electrodes. For determining the stratigraphy using the electrical resistivity test, the inverse slope method is used, and you would plot electrode spacing versus A by rho A, the apparent resistivity in the denominator here, and you can see where the change in slope occurs. That is the where the strata occurs. You would have to match it with the borehole data to determine the stratigraphy. Electrical resistivity tomography or imaging, this is a more advanced technology. Here you have digital data acquisition. You use a grid of 50 to 100 electrodes, and with electronic data acquisition, you can identify the various horizons of the ground with different resistivities and interpret them for the various strata. Seismic refraction test. This has been very useful in particularly on metro projects and various other projects where you want to get the profile of the rock, and you can very easily assess the trend of the rock formation. And you can see here whatever boreholes were done, the strata is matching quite well. So you can identify the various layers of the rock from the along the long alignments. This is an SASW test. This was done at the Commonwealth Games village at Delhi. So from this you get the average shear wave velocity, and this is used for the various foundation analysis, liquefaction studies, etc. So now I will move on to a case study demonstrating the application of these tests. This is a refinery project expansion in Bihar. The site is in the Indo-Gangetic alluvium. The various facilities planned include heavy equipment for the polypropylene recovery unit, PRU, and associated units, mounted bullets, and large diameter storage for petroleum products, and various other facilities. So the scope of the investigation here was 19 boreholes to 30-meter depth, SPT analyzer test, electric cone penetration test, pressure meter test, cross-hole seismic test, etc. In the PRU unit, 4 boreholes, 3 electric cone penetration tests, 1 pressure meter test, and 1 cross-hole seismic test was done. So what we are presenting here is for this particular unit, how the analysis was done. What is the benefits accrued by performing the advanced testing. So this is the borehole data, which shows me that up to about 7.5 meters, I have sandy silt. Some clays is also there in this layer. Then below that, I have sand. SPT energy measurement was done, and as you can see, the average value of energy transfer here was 73.8%. So you can correct your N values for the energy transfer. So I had the corrected SPT values corrected for energy, and also, of course, overburden and dilatancy effect. So now IS 2131/1981 This code is also under revision. The draft code is under circulation. It should be implemented very soon so that you now have to measure the energy transfer during SPT. The electric cone penetration test. This gives me the cone tip resistance, the sleeve friction, the pore water pressure, and then the interpreted soil behavior type. So we are able to interpret the various layers here. Top layers, clay and sandy silt, and then down below we have sand. So this is the soil behavior index, so that we can classify what type of soil is there at various levels. This is the pressure meter test results, profile of the limit pressure and the deformation modulus with depth. The in situ horizontal stress was determined from the creep volume, and the pressure at which the creep volume is least corresponds to the horizontal stress. The probe comes in contact with the soil and overcomes the in situ stress. So the results of the cross-hole seismic test, you can see the shear wave velocity and the primary wave velocity here plotted with depth, and also the dynamic shear modulus and the dynamic Young's modulus. Using this data, now various correlations were developed. Robertson and Cabal, they have developed various correlations from the QC friction resistance and the soil behavior index. So these correlations have been used to determine various parameters like C5, gamma, modulus of elasticity, consolidation parameters, etc. Correlations are also available between the pressure meter test and various properties of the soil. Also, the cross-hole seismic test data, these can be interpreted to evaluate some of the parameters. So the boreholes, all the data from these various tests have now been evaluated to assess the correlations and the trends so as to develop a design profile for the foundation analysis. So firstly, I look at the N values, SPT, this blue one tells me the corrected SPT N60, corrected for 60% energy. And this brown line here gives me the values interpreted from the CPT profile. So looking at it's a reasonable match. On basis of this, a design profile has been selected for the foundation analysis. Now let us look at the fines content. Also the fines content can be determined. These are the actual laboratory results. These dots in blue and this brown curve gives me the fines content interpreted from the CPT. So there is a reasonable match. Density, total unit weight. You can see the actual measured density from the undisturbed samples. Also from the CPT results and the SPT correlations, all the values are falling in a narrow band. The C value, cohesion intercept. Now we can interpret this from the pressure meter data, from the CPT results. Also, we have the laboratory results and also correlations from SPT. So you can see the trend of the values here Some places there is some scatter, but otherwise it's in a narrow band. So only thing is that the C value interpreted from the SPT is somewhat lower. Other values are in good match. Angle of internal friction, this is in the sands. You can see what you interpret from pressure meter, from the CPT, and as well as laboratory results. Laboratory results are somewhat lower, but there is a reasonable match. Then I come to the modulus of elasticity. There are various correlations presented by Bowles. Robertson has a correlation which he is using for determining the E values in sand. Then there's the pressure meter deformation modulus. And also from the cross-hole seismic test, Haberfield had suggested that the dynamic E you divide by 5 and you get the static. The pre-consolidation pressure and the over-consolidation ratio all matched with laboratory tests. There are some variations here and there, but otherwise there is a reasonable match. The over-consolidation ratio, as you can see, is within the general trend of CPT. The in situ horizontal stress, this was very revealing that from the pressure meter, you can get a very good assessment of the actual in situ stress, horizontal stress. The shear wave velocity can also be determined from the CPT. And if you were to determine the shear wave velocity from the cross hole and compare it with the CPT, there is a very good match. Now, liquefaction analysis was done, and the liquefaction analysis showed that SPT, the liquefaction may occur from 7.5 to 10 and also 20 to 22 meter depth. From CPT, it was showing around 7.5 to 14.6, and shear wave velocity was also showing liquefaction. Plotting all these graphs for the foundation design, the liquefaction was considered 7.5 to 14.5. So this is a design profile selected on the basis of the various tests, C, phi, gamma, modulus of elasticity, all these from the different profiles. So with this, we were able to make a very realistic selection of the design profile, and with all the variety of in situ tests available, the modern investigations should be effectively be able to collate your data from various tests so as to select the realistic design profile for the foundation analysis. So improved ability to characterize the subsurface is very important so as to evaluate all the geotechnical issues on the project. So once you have improved quality of data, good data acquisition, digital data processing, all this can assist you in analyzing large quantum of data. Otherwise, analyzing a bulk of data would be very difficult. So this can enhance the geotechnical engineer's ability to characterize the soil variability and the uncertainty in the soil properties so as to predict the soil behavior correctly. This is what is the basic important thing to be able to really get good assessment of the soil properties. So what I would like to emphasize here is that go for CPT, CPTU is a very useful equipment, a very useful tool to get the right quality of geotechnical data. Pressure meter tests also help you in getting a good assessment of the soil behavior. Uh, Always geophysical tests for liquefaction analysis, for foundation analysis, for machine foundations, etc. It's a very useful tool in getting the profile of the shear wave velocity with depth. And this is very essential to be able to perform the necessary foundation analysis. So with this, uh, I close this presentation, and I'll be happy to take questions. Please put your questions in the chat box and I will respond to it.
There's some. Thank you, sir, for your enlightening presentation. Now let's move on to the QA session. We have
Sorry,
received
there was
some.
some internet issues, so there was a small break. Yeah, we proceed now.
So there are some questions. The first question is from Jose Lopez. How does cohesion influence control fill soil according to ASTO, which considered a cohesion of 0 kilopascal while taking the account that induced anthropogenic cohesion may occur?
How does cohesion influence controlled fills? Now, if you were to consider a cohesion of 0 kilopascals, it would be considering treating it as a sand. But if you were to use cohesive soils, the C value would not be zero, it would be substantial. And if you were to do controlled filling, you could get quite a value of phi of cohesion intercept, that is C, which may be on the order of 70 to 100 kilopascals. Uh, if the cohesion happens to be zero, then you are using a sand for your controlled fill. I hope that clarifies.
Thank you, sir. Thank you, sir. Next question is from
Is CPT more effective in soft soil or hard strata? CPT is definitely very effective in soft soils. As far as hard strata is concerned, as long as refusal is not met, you can push the CPT cone. You will get the properties of the hard clays and dense sands very effectively. How can QC data be interpreted for soil analysis? The QC can directly be used to determine your bearing capacity and settlement. You can look at IS codes 8009 part 1 for the settlement analysis. There are correlations by Robertson, Main, and other authors which give better interpretation of CPT for foundation analysis. So you can there are various correlations available from which QC can be correlated to C, phi, gamma, and other parameters. So you can get a very good assessment of the soil from the QC data. Thank you, Renu.
Uh, Next question is from Raj Dhawan. What is the maximum depth up to which CPT can be done?
Now, the depth to which CPT can be done would depend on at what depth you get the hard strata. If your strata is very soft, you can even go to 80 to 100 meters. And if you get shallow rock or hard soils with SPT more than 60 or 70, the CPT would be terminated at that depth. So basically, it would depend on the how hard your soil is. So if particularly in soft clays, it has been the test has been done even up to 100-meter depth. Thank you.
Thank you, sir. Next question is from Abhinav Dikshit. Can CPT and PMT value may be directly used for designing the pile foundation?
Certainly, yes. You can determine the parameters from the CPT and pressure meter. You can use it for pile capacity analysis and determine your pile capacities in compression, pull out, as well as lateral. So you can definitely use it for pile capacity analysis. Thank you.
Next question is from Arun. How does India's diverse soil impact geotechnical investigation methods?
Very interesting question. First of all, you have to assess the general trend of soil characteristics at a particular location. If we are looking at the Himalayan areas where rock is shallow, then you are probably doing drilling through rock. You would probably want to use a triple tube core barrel to get good quality rock samples. In the Indo-Gangetic alluvium, you have very thick alluvial deposits. Here you are going to be using your various tests like borehole, CPT, pressure meter, etc. If you were to go into the areas in the Deccan Trap, you have the stiff to hard clays. There again, pressure meter and CPT give you very good results. Again, if you were to go south, where rock is at shallow depth, particularly in Karnataka and other areas, again you would be doing drilling through rock. So you would have to understand your deposition before you can decide on what kind of investigation methods you are going to use. Thank you, Arun.
Thank you for answering the question, sir. Next question is from Vanya. On what basis we can choose the points of SPT and bore holes? Points on for SPT and bore holes.
On what basis can we choose the points for SPT? So basically, it depends on what you are constructing. So your building layout should be clear. As long as you have the building layout and you know where the loads are coming, so you would select your points for boreholes with SPT accordingly, so that the heavily loaded points are investigated properly. You can supplement that with CPT so that you get a good assessment of the soil behavior, and use both of them together to be able to get the right kind of foundation analysis.
Okay, sir.
Thank you.
Next question is from Mukesh Pichali. Why CPT gives higher cohesion compared to actual undrained cohesion of the soil?
Uh, the CPT is an in situ test. It does not get affected by sample disturbance. Therefore, it gives you the in situ values. Whereas if you were to collect an undisturbed sample from the ground at some depth, um, bring it to the laboratory and test it, that would have an influence of sample disturbance. So the actual undrained cohesion would probably is what the CPT is giving, not what your laboratory result is giving. I hope that is clear.
The last question we are taking today is from Summer. What should geotechnical engineering students prioritize in their studies?
Uh, it's a very tough question, Summer. Depending on what your interests are, because investigation, which I have presented here, is only a very small part of the entire spectrum of geotechnical studies. You have foundation analysis, you have slope stability, you have geotextiles, you have various other disciplines, sub-disciplines within geotechnical engineering. So, most important is what excites you, and everything, all these subjects which I mentioned, career-wise, there is a lot of scope. Ultimately, it is you who have to decide that how you are going to build your career. It may be difficult as a student to be able to take that call at that stage. Probably your professors can guide you better than what I am saying here. But yes, if geotechnical engineering excites you, there is a big scope available, and different specializations within geotechnical engineering, slope stability, foundation design, geotextiles, uh, various other subjects are you can work on. Best of luck to you. Thank you.
Thank you, sir, for addressing these questions with such clarity and expertise. As we come to the end of today's webinar, I want to express our gratitude to all our attendees for joining us. Your participation and engagement have made the session truly valuable. We hope you found today's discussion informative and inspiring. If you have any further inquiries or would like to continue the discussion, please feel free to reach out to us via mail or our social media channels. Again, thank you. Thank you, sir, for giving
Thank you
the
very much.
best insight.
Thank you very much. At Cengrs, we have always believed in technical sharing of knowledge, and you're always welcome to work with us together for clarifications on many technical issues. We'll be there to support you. Thank you very much.
Once again, thank you all. Thank you all for your participation. We look forward to seeing you at our future webinars also. Have a great day.
Great. Thank you.